Greetings. Welcome to our 33rd episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign.
And hello, everyone. My name is Jen Miller, and I'm the coordinator of the Fabricated Geomembrane Institute, or the FGI.
On today's episode, we're going to focus on our August 12th, 2021 webinar titled Leachate Collection Systems Design and Management. I'd like to quickly reintroduce our speaker, Bob Mackey. Bob is a partner, senior design engineer, and senior project manager with S2L Inc., a consulting engineering firm specializing in waste management issues and waste containment facilities. Bob has broad-based experience in solid and hazardous waste issues. Bob is also past chairman of the ASTM D35 Committee on Geosynthetics, former technical program chair of geosynthetic conferences, and an adjunct instructor at the University of Central Florida. The title of Bob's webinar is Leachate Collection System Design and Management, Part 1. Part 2 will be scheduled for early 2022, where Bob will discuss detailed calculations for sizing leachate collection systems. Bob, thanks for squeezing this podcast into your busy schedule and joining us from Orlando, Florida. I would like to go over the questions we received during the podcast and the webinar and after the webinar that we were not able to get to immediately after your presentation. So welcome again, Bob.
Thank you.
Okay, here we go with the first question. Regarding repositories that are filled and covered in a short time frame, what are your thoughts about basic vertical sump riser pipes angled up the side slope? Pros and cons with regards to long-term leachate monitoring and pumping as needed after final closure.
Okay. Well, the vertical riser pipes are more typical than what an engineer uses in, I think, typical environmental designs like sanitary sewer systems versus the angled risers that go up the side slopes, which is what a lot of landfill designers use. I have I have nothing against vertical pipes. I mean, a lot of people are comfortable using those vertical riser pipes. The issue I see is that when you look at the typical sanitary sewer pumps that are used, you have a base for your, basically a manhole. You have to put a pad on there to protect from the vibration of the pump. And then the impeller system's on the bottom and the motor's on the top. And to keep it from burning out, you need to keep that motor within the liquid so it has a cooling action on it. So, and you usually go several inches above that motor. The issue I have, or I don't like using the vertical standards pumps because the angled sumps are usually a tubular pump that lays laterally along the base of the landfill. So you don't need to have as much liquid within your sump to activate the pump itself. So thereby you're keeping the minimal amount of head over the liner system. That's why I think the pro of the sump pump that lies lateral is better leachate removal, less head in the liner system. I don't really see a con in it. The pro of the vertical is that it's something you're more familiar with. You understand it better, but the con is that it's going to take more leachate head within your manhole to activate the pump, and you're going to have more head over your liner.
Yeah, and Bob, if this viewer is thinking of MSW facilities, of course, there's a down drag or due to the waste settlement that could also be a con for the vertical sump. Any thoughts on that?
Well, there is, but there's really not much of a down drag. I mean, what happens is the waste settles around it anyway. When you look at landfill gas collection pipes, they're basically a pipe, there's rock around it, and it's more or less a pylon. The waste is still going to settle around it. It's not going to drag it down or compress anything. So I don't see a settlement as being an issue. And you still got a big pipe you're going to have to connect a boot to in your closure anyway. There's going to be settlement around that, vertical manhole.
Yeah. Okay. Bob, next question from during the webinar. Has temperature been factored into your calculations? Hotter temperatures cause ongoing compression of the geosynthetic drainage composite.
No, I haven't dealt with the calculations or the temperature aspect into the calculations. I think the sim tests that a lot of people are starting to use may help in that area. The question is that you talk about ongoing compression of the composite drainage nets. Well, you have to look at the time factor in which this is going to occur. The composite drainage nets are laying on the bottom of the liner system. The soil below it is going to have a cooling effect. The waste above it is going to be hotter, and it's going to bring leachate down and bring that temperature to the liner system. So how long will that leachate continue to drip down and you're being impacted by the heat within the landfill cell? I know that once you do go over our closure, you stop liquid from getting into the landfill cell, which thereby slows down the decomposition process and thereby slows down the heat generation. If I was really worried about a long-term impact of the heat, I would increase my reduction factors for creep based on that concern and use a higher creep reduction factor within the calculation.
Okay, thanks, Bob. The next question is, if a geocomposite is specified for the lateral drainage layer, what is your approach to protective cover soil design / specifications?
A lot of regulations require 1 × 10⁻³ centimeters per second hydraulic conductivity of that drainage layer. If you specify a composite drainage net as your primary drainage layer, some states will allow you to have a lower permeability of soil on top of that composite drainage layer, the CDN. It'll save you money, but you also have to look at that if you have a lower permeability soil, that usually means it's going to have more fines. More fines means that could be more fines entering through the geotextile and being trapped within the geonet of the composite drainage net. There's also being a tiner matrix within that soil, greater possibility of biological clogging on the surface of the lower permeability soil. So my approach still is, even though I'm specifying a composite drainage net, which allows me greater lateral spacing, I still go with 1 × 10⁻³ soils over the composite drainage net for good percolation through and into the CDN.
Yep. Great, Bob. Next question. You mentioned that you do not prefer large diameter perforations within the collection pipes. Why is that?
Well, within the presentation, I talked about larger perforations mean you have to select a drainage stone around the pipe that is larger also, and that there's a cost associated sometimes with a larger material. What I didn't talk about within the presentation is that if you go with a larger stone, you're getting a point force caused by this angular stone a fewer number of points per square foot. So you're going to have to worry about more penetrations, or the possibility of penetrations due to the larger rock. You're also going to have to worry about the point of pressure on your drainage. The drainage rock is on the pipe itself. So I really stick to what saves my client the best money in looking at what's the most common stone out there for my area, and then I check to see what kind of perforations in the pipe will work with that stone. And then I start calculation the flow per linear foot flow path into that pipe, and see if that preparation will work under a certain head. And so I backtrack a little bit, and that's where I base what I really want to make my design about. Now, it may be different in different areas where a larger stone is more common than what we typically have here in Florida, 57 stone. So you have to take those concerns of the increased pressure on point pressures on the CDN and the point pressures on the pipe to make your decision on how do you protect the CDN, or if you're going to have to increase the SDR on the pipe itself.
Great suggestion, Bob. Start with the cone and the stone, and then work backwards to the pipe perforations. And because there's probably more money involved in the stone. Great suggestion. Okay, Bob. Next question: is there a concern with blinding the fabric wrapping the leachate collection column by wrapping the stone with a non-woven geotextile? Does this increase the risk of cutting leachate flow off from the biological and sediment clogging the geotextile?
Yeah, well, that's the big debate, within the presentation itself, which is better, leaving a textile and a drainage material over it, or open it up and allowing the rock be in direct contact with the waste. To me, it really comes down to how long the system is going to have to function over time. If I'm in a valley fill, I may want to have a lot more stone in there and not have the textile, because I'm going to get leachate percolate down through the waste and into that drainage rock and pipe over 20, 30 years versus what I would typically see when you're building a pyramid landfill of, say, only 5 years. So it really comes down to what the designer knows about the landfill he's designing and the life expectancy of the leachate collection system for any particular period of time.
Right. Okay, Bob, next, any thoughts on butt fusion welding versus electrofusion welding for the leachate collection piping?
Well, when it comes to butt fusion welding, there's no problem with it. I mean, they use it all the time when they have to cut in pipe. One issue we saw is that if the pipe within the butt fusion coupling, I guess you would call it, if it heats up, it starts melting the plastic to kind of join it together. And we actually seeing beads of high density polyethylene flow out one of the perforations. So I would prefer only the butt, so it looks like a little finger sticking out into the pipe. I would prefer the butt fusing mostly on, solid wall pipe and not perforated pipe, but sometimes it just can't be helped, and you have to deal with any kind of extrudate that comes in.
Bob, do you have a recommendation for the number of sumps for the size of the waste cell?
No, I don't. It really comes down to the value of the airspace. Now, what do I mean by that? You have a sump, which is your lowest point in your cell, and your pipes are flowing into your cell, which means from that sump, it's flowing up gradient for your leachate collection leachate collection laterals and your header pipes. And it's the wider you get, the more those header pipes are going to extend out further, and any pipe that goes off that header pipe will again increase in elevation. There comes a point where the cost of the airspace you're taking up by trying to reduce the number of your sumps is not worth it. It's cheaper to have an additional sump versus the airspace you're recovering from your cell. And you should be able to calculate what that value of that airspace is and your cost of your sump and make that kind of determination.
Yep. Yeah. And of course, figure in the local tipping fee, and that's a great suggestion.
Yeah.
Okay, great, Bob. The next question is fairly long and detailed about lysimeters, but here we go. Would an additional protection under the LCRS sump be representative of the liner under the rest of the cell? For example, if a leak detection system or unsaturated zone monitoring system, a pan lysimeter, is installed below the LCRS and you add additional protection between the bottom of the LCRS sump and the detection system or lysimeter, it's not representative of the condition over the entire cell. The liner system in the sump area should be exactly the same as the liner system below the rest of the cell. Otherwise, it's misleading to the regulator on the condition of the liner system. So there's a lot there, Bob. I'll let you take it apart.
Well, this gentleman this person is thinking about a double liner system.
Yeah.
Okay, and he has a great point. It would be not representative of what is actually leaking out. What I'm talking about in the additional protection would be probably under just a basic one liner composite liner. And that's it. I mean, under a simple single layer composite. So he's correct. You want the leak detection system to be representative of what is actually occurring within the cell.
Yeah. Okay, Bob, what do you think of using crushed limestone for leachate drainage media with regards to the potential for clogging or degradation?
I'm not in favor of using crushed limestone for the simple fact that once limestone gets wet, it starts adhering to itself and starts losing its hydraulic conductivity. Also, you have the acidity of the waste that's dissolving some of the calcium carbonate within the limestone. And once it gets into the pipe, it could start clogging the pipes. I know that within the islands, that's the only material they have. You're not going to ship in a bunch of sand or drainage rock. You're going to use what's available. So if you're going to use less crushed limestone, you're probably going to need to make it as large as possible and protect your liner system due to the large aggregate size.
Right. And so, Bob, if you go with that limestone, should you have a filter fabric or non-woven geotextile below that limestone to catch some of the degradation, or just put the rock right in contact with the pipe?
I would put the rock right in contact with the pipe.
Okay, great. Okay, Bob, next, what percent slope is ideal for a leachate collection pipe?
We look at probably 10 to 20% over scouring velocity for the pipe. And so you look at the size of the pipe, what's the scouring velocity, and you know what it is, and you just kind of increase the grade of the pipe or the slope of the pipe prior to what you think the settlement is going to occur in the landfill. So we look at probably 0.3% or 0.5% for scouring velocity, depending on the pipe size. That's just off the top of my head. You really need to do the calculation.
Okay. Next, there is a lot of research on reduction factors and different drainage geocomposites. What are your views on different geocomposite materials like cuspated drainage sheets, geonets, which you talked about, drainage tubes, etc.? And any comments you have on the various reduction factors?
Well, when it comes to different materials for composite drainage nets or geocomposites, it really comes down to is how long or can they take the load that's being generated at the bottom of the landfill, and what's that load going to do to this material over time. So if you're going to use something other than the standard composites, you need to research those areas. Anything will work. That's a possibility, but it comes down to more knowledge and doing the research on it.
Okay, thanks, Bob. Could you define CDN and CGN again, please?
Yeah, I've always used composite drainage net versus, I guess, CGN is composite geonet. They're kind of interchangeable. Some people just call them geocomposites, but in many ways within the technical community, a geocomposite could be a GCL, which is bentonite and geotextiles. So within my usage, they're all the same. It's just I rather use the word composite drainage net as a much straightforward, better defined term.
Yeah, Bob, that's a real confusion. Maybe with your past chairman of D35, you could get them to look at it, because you've probably seen GDC, DC, many different acronyms for a drainage composite.
Yeah, a lot of the geosynthetics, came more or less, a name was a slang that someone used. And what ISO has done is try to qualify it a little bit more in regards to exact terminology. So they've done a better job of, the ISO standards done a better job of defining terms that are more specific to an exact product out there.
Yeah. Okay, Bob, I want to switch gears to the questions that were submitted after your live presentation, and these came in through the post-webinar survey that Jen Miller sends out. So here's the first one. With good puncture protection design, is there any reason why an LLDPE reinforced geomembrane could be used for the bottom liner system with comparable mechanical properties for a MSW landfill? They say traditional landfill, so let's start with MSW versus the traditional 60 mil HDPE geomembranes.
Well, I'd have to go back into the history of EPA's research into various liner materials. They were looking at what would be the best resin to use or membranes to use for landfills. And they found the high density polyethylene was the best because of its broad range of chemical resistance. Now, high density polyethylene is just that, it's high density, it's very tight, where linear low density is a looser dense material. So I'm not sure if it would have similar chemical resistance. Let's see, there was also one other item about the resistance. I had another point and I can't think of what it is right now, but I think the chemical resistance is the big issue. Oh, I know what it is. Another thing is because of the tightness of the material, there's a lot of concern about gas uh, uh, migrating through these membranes. And I would think you might have gas diffusion through the LDPE at a greater rate than the high density polyethylene liners. I don't know that for a fact, but that is an issue of concern with several states.
Right. And those are great points. And if the viewer is interested, of course, they could run chemical resistance tests, maybe the 90-90 test, and make sure that the LLDPER performs as well as the HDPE.
Well, there's been a lot of gem membranes that try to get to the market, and to do the kind of chemical analysis or resistance is pretty expensive, and a lot of times they're just either they don't the expense or they didn't get the results they wanted.
Oh, well, then why they should run the test, I guess. But okay, yeah. All right, Bob. Next one. Also, what effect does baseliner or bottom liner wrinkles have on leachate collection systems?
Well, if you just look at the thickness of a composite drainage net, being about 1 centimeter, and you have these wrinkles and rolls that may fold over or still exist when you're putting the liner system down, it's going to inhibit the flow to the leachate collection laterals. Here in Florida, that attention was brought up quite frequently because it's very warm in Florida, especially if you're putting a liner system in during the summertime, and you're going to get a lot of wrinkles. But we also have double liner systems, and we really haven't seen an impact on leakage within the leak detection layers from excessive wrinkling. So it hasn't been a concern to regulatory agencies here in Florida. The key is just try to minimize as much as possible. You want to, probably cover that geomembrane in the morning when the wrinkles aren't there, and proceed across the cell that way.
Yeah. Okay, next one. Regarding repositories that are filled and covered in a short period of time, what are your thoughts about basic vertical sump riser pipes compared to sump risers? This looks very similar to the question you started with, Bob.
Yes, and I think we previously answered that.
Yeah, okay.
Okay, so we can move on. Have you seen variable speed pumps used to remove leachate to minimize start-stop cycles, reduce energy consumption, and prolong pump life?
Yes, variable speed pumps have been specified on projects. The issue on the variable speed pumps is usually they're more expensive. So if the client wants them, and so he doesn't have to sub out or switch out his pumps, then go for it.
Okay, Bob, next question, second to last. Great insights, truly appreciate your experience. One area that might be helpful for follow-up is to touch on the pipe crushing / deflection side of things with respect to the details of the lateral cross sections.
Yes, well, I'm going to reference back to the Plastic Pipe Institute. They have design manuals that we use to do our calculations. They're a step-by-step process that goes through the design, and we'll touch on quite a bit of that in the next presentation. But you don't want to wait. Get onto the Plastic Pipe Institute's webpage and download the manuals.
Right. Bob, with the increasing trends in precipitation, and I think they're thinking of global climate effects, are you seeing or recommending landfills assume larger leachate generation rates during the active life of the landfill?
That's the first time I've heard that question. And let me say that, we use the help model quite a bit, and the model is simply that, a model. It tries to get a good representation. If you're really concerned about that issue, in the past, we've modified some of the data of the help model based on local climatology. For example, you can go to various weather stations in your area, download the average monthly rainfall events, or what it is over the last 5-10 years, and you can take that average and input it into the help model so that the help model output is more responsive to your localized area instead of the general area the help model uses. You can also adjust the coordinates of the landfill to adjust for the evaporation constants and things that goes into the help model. So you can adapt the help model to address that issue if you really have a concern.
Right. And assuming the viewers are familiar with the help model, that's the hydrologic evaluation of landfills, available from written by Paul Schroeder and available through the U.S. Army Corps of Engineers. Okay, Bob, last question. So thanks so much for hanging in there. You calculated a hydraulic gradient of 0.02 for a flow length of 233 feet and 0.0125 for a length of 160 feet. Why is the hydraulic gradient higher for the longer flow length? And I think what they're getting at is hydraulic gradient is the change in total head over the length.
Yes, yes. Well, within the presentation, we talked about the requirement of 2% slope to the leachate collection lateral. But the pipe is also sloped to drain the liquid off the landfill cell. So the slope is not really 2% directly perpendicular to the leachate collection lateral. It's offset at an angle going across to get to the leachate collection lateral. We talked about that significance is that when you look at a biplanar product, it will flow in direction that the slope of the bottom of the landfill is, which is often an angle to leachate collection lateral. But if you have a triplanar product, it has a more of a unidirectional flow directly to the leachate collection lateral. So the idea here is always test the composite you're using based on the actual flow that's going to occur with that material within the landfill cell. So the shorter distances for example, was a triplanar of only 160 feet at a lower slope versus the biplanar that would have a longer distance to flow to the lateral, but it's going down at a steeper slope of 2%.
Right. That's great, Bob. And I suspect you'll get into some of those calculations in your second webinar, hopefully.
Hopefully, yes, I should have it all.
Okay, great, Bob. That's all the questions. Thanks so much for joining us again and answering 19 questions following up your webinar. If you have any additional questions or would like to get additional information, you can send your questions directly to Bob at bmackey, B-M-A-C-K-E-Y, at s2li.com. Or you can email the questions to the FGI at fabricatedgeomembrane@gmail.com, and we will forward them to Bob. So Bob, thanks again for a great webinar and answering these 19 extra questions.
You're welcome.
Great, and we'll see you in early 2022 for session number 2 on leachate design and management.